Hello, everyone. Welcome to Brain Blitz Audios. In this episode of NEET preparation, we'll be dealing with previous year questions of physics in medical entrance examinations in India. The chapter that we'll be dealing with is the first chapter in the grade 11 syllabus for CBSE, which is asked in exams, that is, units and measurements. Now, I know you might be feeling like let's take another one question, view it, and then go out. But I urge you to watch this video completely to get a full idea of what is going on. So let's begin, shall we? Here is our first question. The velocity of light is equal to root of 1 by E naught epsilon naught, 1 by epsilon naught mu naught, root of epsilon naught by mu naught, epsilon naught by mu naught, or epsilon naught into mu. So let's look at this question. So over here, epsilon naught is permittivity. It's a constant. And mu naught is permeability, another constant. So epsilon naught is used for electrostatic force, and mu naught is found in magnetic force. So the relation between these two is given as epsilon naught times mu naught is equal to 1 by c squared, where c is the speed of light. So therefore, we can write c squared as 1 by epsilon naught mu naught. And therefore, c will be equal to whole root of 1 by epsilon naught mu naught. Therefore, option A is the right answer. So now we move on to our next question. Using mass, length, time, and current as fundamental quantities, the dimensions of permeability are. So in some questions, you might get different dimensions to be used as fundamental quantities, but over here, it's the MLTA system, so it's still the same. So what we have to do is we need to find the dimensions of permeability. Permeability is mu naught. And in order to calculate the dimensions of permeability, it's best if you know the formula for magnetic force. So the formula for magnetic force is F is equal to BQV. And where F is force, B is magnetic field intensity, Q is charge, V is velocity. So that's that. But there is no mu naught in this term. How do you put mu naught into this term? So B, magnetic field density, is given as mu naught Ni. So therefore, we can write force as mu naught Ni QV. So this is our formula that we'll be using. So a couple of pointers. Mu naught is permeability. N is the number of turns of the wire per meter. So it's a sort of density. And I is the current. Okay, so the formula is in terms of force. Now we need to change this in terms of mu naught. So let's take mu naught on the left-hand side. So force, and then all the other quantities will be at the denominator. So it will be F by NIQV. So this is how we use this formula. So we found the formula in terms of mu naught, that is permeability. The next step is to put the dimensions of all the quantities here. So the dimensions of mu naught can be given as the dimensions of force, which is mlt power minus 2, mass times acceleration, divided by n, which is the number of turns of wire per meter. So its dimensions is L raised to minus 1 because of per meter. And then I is current. And so that is AT because I is equal to Q times, because of the formula, I is equal to Q by T. And so Q is equal to IT. So basically, we're using the charge, denoting the charge using AT, because A is for the current. So therefore, we'll have A as well, singularly, because we have I as well. And finally, we have velocity, which we will represent as LT power minus 1. This is displacement by time. Now, let's simplify the denominator. So L raised to minus 1 plus 1. So that means that L raised to minus 1 and L can cancel each other. T and T raised to minus 1 are also getting canceled. So in the denominator, so we'll get MLT power minus 2 divided by A power 2. So we can write 1 by A square as A raised to minus 2. So therefore, the dimensions of permeability are MLT power minus 2, A power minus 2. So these are the dimensions of permeability. And when you look at our options, we find that option C is the right answer because it has the same option, MLT power minus 2, A power minus 2, which we found out by calculating. So this is how you calculate for permeability using the formula F is equal to BQV and B is equal to mu naught Ni. Next question. It's the similar question, but this time we have to find the dimensional formula of permittivity. So the fundamental quantities are mass, length, time, and current. So we need to find permittivity in terms of mass, length, time, and current. Permittivity is E naught, and the formula that we'll be using is the formula for electrostatic force, which is 1 by 4 pi epsilon naught Q1 Q2 divided by R square. So note that most of these formulas that we have are found in grade 12, and since you're attempting NEET after grade 12, most of these formulas will be memorized by you, so you would know which formula to use. So F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where F is electrostatic force, and Q1 and Q2, these are charges. R is the distance between the charges, and 4 pi is just another constant. Epsilon naught is permittivity. So now we need to write this formula in terms of permittivity. So over here, it's easy. We just take permittivity to the left-hand side, so it goes to the numerator, and force to the right-hand side, which goes into the denominator. So basically, the formula becomes epsilon naught is equal to 1 by 4 pi F times Q1, Q2 divided by R squared. So now let's write the dimensional formula of permittivity. So 1 by 4 pi is a constant, so it has no dimensions. But Q1 and Q2 have dimensions. So these are the dimensions of charge. which again is AT. AT because charge can be represented as current into time. So current A into time T. Now we divide it by force. So the dimensional formula of force is mLT power minus 2. That is mass times acceleration. And r square will be represented as L square because r is distance, and that is L, length. So let's simplify both the numerator and the denominator. AT times AT gives A square T square. And in the denominator, L raised to 1 plus 2 gives L raised to 3. So it'll be M L cube T power minus 2. So 1 by M will give you M raised to minus 1. 1 by L cube gives you L raised to minus 3. And over here, it's T raised to 2 plus minus of minus T raised to 2 minus of minus 2. So that will be T raised to 2 plus 2. So T raised to 4. So the dimensional formula for permittivity is M raised to minus 1, A square, M raised to minus 1, L raised to minus 3, T raised to 4, and A raised to 2. So let's write it down. M raised to minus 1, L raised to minus 3, T raised to 4, A square. So this is the formula for permittivity. So that is option B. So option B is the right answer for the dimensional formula of permittivity. Next question. Parsec is the unit of time, distance, frequency, or angular acceleration. Angular acceleration has the unit radian per second square, where radian is the plane angle, which can be written as angular displacement. So option D is incorrect because that is not parsec. It's written as radian per second square. What about option C, frequency? Frequency has the unit hertz, cycles per second, or turns per second, etc. So the unit is hertz, so it's not parsec. So option C is incorrect. Now, what about option A, time? Now, since it's written as parsec, you might think that it has something to do with time, but no, time is not the actual quantity for which parsec is a unit. The units of time are seconds, minutes, years, months, millennia, eras, microseconds, nanoseconds, etc. But there is nothing called a parsec. So option A is incorrect. The right answer is option B, distance. Parsec is actually a unit of distance. The reason being, parsec is an astronomical unit of length. So it's an astronomical unit for distance. And parsec is, so let's write it in the next page so we can write a complete definition. So the parsec is the distance of an object that will show 1 second, which is an angle basically. So this is written as 1 second. So 1 second of arc from opposite sides of a baseline equal to the distance between the sun and Earth. So suppose we have an object here and we have a baseline equal to the distance between the sun and the Earth. And so let's draw a line like this. So when this angle is 1 second, the distance of this object is a parsec. So 1 parsec in meters is 3.1 into 10 raised to 16. So 1 parsec is 3.1 into 10 raised to 16 meters. So the right answer is option B, distance, because parsec is an astronomical unit, which can be found using the parallax method. Next question, the dimensions of electrical resistance are. So how do you use electrical resistance? In grade 10, you've studied V is equal to IR, the Ohm's law. Therefore, this R is the resistance. So what we do is we rewrite this formula as R is equal to V by I. So this is simple, right? But we need to convert it into something which we can express in dimensions M, L, T, and A. So how do we do it? Now, since the potential is equal to work divided by charge, we can write R as W divided by QI. So now let's find the dimensions of resistance. R is equal to the dimensions of work is ml squared t power minus 2, force times displacement, divided by AT is the charge and A is the current. So this will be ml squared t power minus 2 divided by A squared t. So it'll be t raised to minus 2 minus 1, so it'll be t raised to minus 3. So ml squared t raised to minus 3, A raised to minus 2. So this is the dimensional formula of resistance. So that's all for today's episode of NEET preparation. There are a lot of questions for all of the chapters in NEET, but due to time constraints, we only can show you so much in one episode. So please stay tuned to each of our episodes right here on NEET preparation and Brain Blitz audios. I'll be providing some of the links in the description down below for the playlists. So if you like what you saw, please subscribe to our channel. We'll be back with more useful and interesting content such as learner words, mind maps, NEET preparation, etc. So until the next episode of NEET preparation, take care, stay safe, ta-ta for now.